Hi, my name is Tim Lindquist. I'm a professor in the software engineering program at ASU, and this is a video that supports our course in mobile systems, Ser423. Today what we want to talk about is Android Studio, kind of give you an introduction to Android Studio and develop a first fairly simple app in Android Studio to kind of look at the basic UI. So there's going to be a single view app in Java on Android Studio. So if we look at the course schedule, you'll see that this is actually in the very first unit where we're looking at Android Studio. There's a section in the Busy Coders Guide, Getting Around Android Studio. We're going to be kind of going through that stuff. And then if you want to, Ray Winderlich, his section on Android Studio goes through installation of Android Studio. This is actually fairly up to date. And some of the other things that you need to do in installing Android Studio, we're going to talk about that as well. Android Studio, it's not the same as installing Xcode for iOS. When you install Android Studio, since it is an integrated development environment that supports several different platforms, if you will, there's some adjoining things that have to be done in order to get Android Studio set up properly. So I'm not going to go through the installation, but I do want to kind of point out those other things that have to exist within Android Studio. Let's go ahead and we'll just create a new project. And my favorite name for a project is Delete Me. This project is just going to be an example project. So we're going to base all of our projects. It's going to be phone and tablet, and for the current version of the course, we're using API 23, which is Android version 6. It's also affectionately called Marshmallow, and in fact that should allow us. And then we're going to use an empty activity. So we'll do that with all of our projects. And backwards compatibility, you know, it doesn't really matter if you use backwards compatibility or not. Actually, with API 23, Android's very different from iOS in that Android, there are many different versions of Android which are still being run actively in phones, and consequently having the ability to do backwards compatibility increases, if you're an app developer, it increases your potential marketplace. So it allows you to kind of balance being able to use the latest APIs, SDK, Software Development Kit, with how many phones it'll actually run on. So backwards compatibility helps with that. If we don't use that, I mean, for the purposes of the course, not using app compatibility is fine. You end up getting some slightly different things in the project, but that's okay. We're not going to worry about that, especially not today. So this is Android Studio. You can see I have another project open up here, but this one will open up in a minute. When you first open up a project, right away notice that when Android Studio is building, across the very bottom, you'll see a blue line that indicates the progress of what's going on while it's building. And Android Studio is set up where there is an editor area in the center. On the right-hand side, we're looking at the editor area. All of the top stuff, as with most other apps, is a toolbar, provides facilities. So, you know, being able to save it, being able to synchronize. There's the run, and actually that's one of the ones that we'll very commonly use, obviously. Another one is sync the project with the Gradle files. What's Gradle? Gradle is a build tool. It's a scripting language that's used to convert the .java files that make up your project to build them into a bundle that gets loaded on the device. Actually that whole build process is one of the components of the class where we take a look at the different phases that go through and that Gradle goes through in order to build a project for you. Okay, so we also have on the left-hand side, so this is the project overview, or the hierarchical form of the project. That's the top left selection. We can look at it from a structural perspective as well. Right now there's only one class. So if there were 10 or 15 classes, the structure would show each of the different classes that are in our project, all of the methods that are in those classes and so forth. And then there's, those are the two most common, captures or screen captures, captures of state captures for an app and so forth. Most commonly we'll be using the project, which shows a logical hierarchy for the development of the project. So it's an app, and within the app is a manifest, and then the Java code that's used for the app. The Java code actually is in three different. There's a test, Android test, and then there's the actual code for the app itself. So almost always we'll be playing with the first of those three. Notice that the packaging, if you look at the assignments and all of the examples that are in the class, you'll see that all of the code that I develop is packaged in edu.asu.sidc.softwareengineering.lindquist, and then the name of the app. Right? In fact, if you're taking a class and a version of it where you're required to hand in apps, you'll be, the packaging that you use for your app is specified in the assignments. So all of the classes that make up my app are shown under here. Right now there's just one activity. And then there is a set of resources that are available for the app. And important are drawable resources. So if we have any icons or any other images that are being displayed in the views of the project, those get put into the drawable directory. We also have a layout directory. The layout directory is where we store the serialized form of views. Both iOS and Android use a model view control approach to developing apps. This is probably one of the more important concepts, not just for mobile development, but for software development in general, where there's a user interface involved in particular. The view is what the user sees, and nothing more. So each of the objects that make up the user's view, buttons and in this case edit texts, spinners and so forth, those lists, those are part of the view. So model view control, that's the view. The control is the code that actually reacts to button pushes, puts data into the view's components. So if it's a list, the control would help specify or react to information that's in that list. And then the model is the underlying data. Very commonly it's a database, or it can also be, in addition to a database, very common that there's a network connection and data comes from a cloud or some other network service. Well, with both iOS and Android, views are not created in code. Instead, they're actually created from an XML version of it. So in this particular case, the activity main.xml is the XML file that is deserialized when the app starts up, and it shows, in this case, there's just one text view is the only thing there, and there's a layout manager for it called relative layout. That text view is just one text line of information that in this case says hello world is the value of it. But in any event, let's undo that. But in any event, that's the way that views are stored in XML, and then they get deserialized. Layouts are the place where all of those are contained. Okay, so then also are the building, the stuff that's necessary for building, project dependencies and so forth. We'll take a look at those as we go on more in the class. And in the editor area, we actually have for the layouts both a mechanism for a designer that allows us to build our views So you can see that in this case, the view consists of one simple hello world text view, and in fact that's placed in the upper left-hand side of the portion of the screen. Okay, well that's not all that important for getting yourself up and running with Android Studio, but what is important is if you look under the Tools menu, there at the very bottom is a sub-menu for Android. And while some of these are repetitive, the two that are not, that we haven't looked at yet, are the AVD and the SDK managers. We'll start with the SDK manager. In order to be able to define the first project, there has to be an SDK. Most bundles for installing Android Studio include a SDK, software development kit, but that's not always the case. Sometimes in the past you've been able to get just Android Studio without the SDK. But the manager is what allows you to update, install, and or remove different software development kits. So you can see here all of the different, I've got SDK platforms selected. This is the SDK manager. It tells, first of all, the location, where on my file system the SDK is located. That definitely needs to be set, needs to be accurate. The installation should set that for you. Most installations do now, but it always happens that depending upon how you get it installed, it may not be the case. And then when you select the SDK platforms, you can see how many different, right? Android 2.1, New Claire, Eclair, all right, all the way up to Android 7.1.1. Which is the second version of Nougat. So as I said, we're going to be using Android 6, Android 23, API at level 23, we commonly refer to it as 23. That definitely should be installed. And if you have that installed, you should be able to run any of the examples that are posted for the class. SDK tools. So when SDK tools, these change in version very rapidly, but in fact, when an update occurs, don't hesitate to install it. You can set it up so that they install automatically if you don't mind being disrupted while you're in the middle of getting something done. Or when you start up Android Studio, it'll tell you, and then you can have it installed then. And then there's a list of the different sites that it'll use. The default is fine for doing updating. So the very first time that you install Android Studio, you need to go into the SDK platforms, and actually there'll be a dialog that'll appear to say that things need to be updated. Because from the time they publish the bundle, the installation bundle, you can guarantee that not only platforms get upgraded or updated, but also the tools get updated. And before you can actually define a project and execute that project, you need to allow it to update. So that's the manager, the SDK manager. And that takes care, so in Android apps are most commonly developed with Java, and Java has a set of base classes that make up the API for desktop environment. Well, those classes are very similar for Android, but not exactly the same. There are several Android classes that are part of Android.util, Android.app, and so forth, different packages, and they are specific to Android and Android apps. In order to get your program, your Android app, to compile properly, the SDK has to be set up properly because it contains all of those class files. It cannot be compiled, although the compiler that gets used is the same as is used on a desktop for targeting a desktop. The actual class files against which your code will be compiled, base classes in the API, are very different. So that has to be set up properly. So the other thing under Tools is the AVD Manager. AVD stands for Android Virtual Device. Here you'll end up, first time you open it up, there will not be an AVD, so there won't be any rows in your table. What you'll have to do is go down here and create one. What we're going to be using are all of the examples that I publish for the class for Android are all based upon Nexus 5 and API 23. Nexus 5 is 1080 by 1920. X by Y, that's its resolution, 1080 by 1920, and that's called XX HDPI, API 23, and then the amount of space that you set up and so forth is completely up to you. The triangle starts up the emulator. We'll look at that in just a minute. If you want to edit it, there's the way to edit that virtual device. And there are several different settings, basic settings and advanced settings that exist that you need to set up. So the very first time that you start up Android Studio, define an AVD. Make sure that you have API 23 with the SDK manager, and make sure with the AVD manager that you set up an emulator for a Nexus 5 API 23 1080 by 1920. And after you've gone through the setting that up, you can actually start up the emulator. So the emulator is exactly that. It's the emulation of a Nexus 5. And this is, you can see, an Android phone starting up. If it has errors coming up, generally don't worry about it. As long as it comes up successfully, that's the main thing. Okay, so let's go ahead and get out of that, and let's just make a very simple app. So one of the big differences in this class between Android and iOS, you will see me very often, matter of fact, most times in Android, instead of using the designer, I will use the actual textual representation of a layout. So what we're looking at now in the editor area is activity main.xml. It is the, when I selected a single view app, that meant that the template was going to create for me a main activity, which is the controller for the single scene or the single view of the app, which is activity main. So if we run it right out of the box, it'll ask for which device we want to run it on, and that's the one we started up. See down at the bottom that it's building, so Gradle build is running. So it's going through those steps of compiling, and then it actually does conversion of the .class files to what are called .dex files, and then it aligns it creates essentially a jar file for it. It aligns all of the code in the jar file, but here you can see it actually is running. All right, so there's my hello world running on this app. You should play with the emulator because it is really an Android device. All right, so there's a calculator app. And so forth. And let's actually go to the next step here in terms of doing some more with this app. I want to show a couple of different things. So part of it is controller. So we want to see the relationship between the controller and the activity main, the view itself. In the controller, when a view appears, it will start up the controller before it does anything else. And after doing a constructor for the controller, it calls the onCreate method in that controller. So that's why a single app controller, the activity main, comes up, and you see the only thing that's in here is onCreate method. The bundle is essentially the APK file that has for us all of the resources that we need available. and then super on create. So we call our parents on create. So in this case, that would be calling app compat activities create on create method. And after we've done that, then what we need to do is to deserialize the UI. And that's done with set content view r.layout.activity_main. So activity main is referring to activity main.xml. So what's r.layout? Well, layout is the subdirectory within the resources, right? So r.layout is referring to one of the files within the layout resource, and activity main is referring to activity main.xml. What's R? Well, R is a generated class. So this is actually a Java class, and this is a static member of that Java class called layout. And the layout property actually has an activity.main, activity_main value, a value for activity_main. It actually turns out to be an integer, but that's okay, it doesn't matter. What this does is to specify to the method set content view. Set content view is a method that is implemented by app compat activity, or actually by all activities and all fragments. We'll look at fragments later on in the course. That actually deserializes it and it makes it appear in the view. All right, so that sucks in our XML and creates the objects that we want to put in there. And then let's look at doing other things associated with it. So let's go into here, into activity main, and let's add something else. Let's add a button. And you can see when I select a button, it's giving me a hints on what each of these different ones mean. But my button, first it asks me how wide I want the button to be. So I'm going to just do wrap content. And how high I want it to be. I'm also going to pick wrap content there as well. Which means that my button is going to only be large enough to contain what I select to put in it. And what am I going to put in it? Well, Android, text, and it equals. So the thing about, so I could type in a literal string here, but it's not going to like it. So I'm going to do click me. And it will take that, but it is not the Android way to get around in the world. And the Android way, we'll talk about why it's the Android way, is to have all of the string literals that are used in an app defined in a strings.xml file, which is part of the resources. Why? Strings are a class in Java, and the string class extends, I think it directly extends the object class, but in creating strings in Java, even literal strings, there's a certain amount of overhead, both in terms of storage and also in terms of time. And Android, those sorts of things on Android devices can actually affect the user experience. And in order to make them more efficient, they're processed in a strings.xml so they can be created separately. So all of our strings that we want to define. So here's a string called click me. That is not the name that's going to be actually appear, but what I type next is. All right, so this string, capital CLICK space ME, is actually what's going to appear on the button, and I'm just going to refer to it with the name click me. So I've defined a new string here in the strings.xml file. So now let me go back to activity main, and I'm going to refer to it here. So instead of having a string literal, what I'm going to do here is have an @sign, @string, and just select the one that I want. Instead of app name, I picked the wrong one. Click me. All right. @string click me. So says there is defined a string. It's kind of like r.layout. string says that there is a string that's been defined, and I want it to be the value that's placed in the button. Now, if we go back to the designer, you can see I now have a click me button, but I don't know if you can tell or not, but it's right on top of hello world. Why is that? Well, this is what's called relative layout, and in order to position things with a relative layout, relative means one object is positioned relative to another object. So let's do this ID. Let's give this text view an identifier. I'm at plus ID, and this is going to be my text view. And now down below, I'm going to position my new, not margin top, layout below equals at ID, my text view. So now I've defined an identifier for the text view up here called my underscore text view, and below I've said I want to position my button layout below my text view. I could have done this with the designer, and actually I encourage you to figure out how to do it with the designer, but as I said, most Android developers go back and forth between using the designer and using this text view. So now if I go back and look at the design, notice that the click me is now below hello world. All right. So now you can see if I go back and execute it, you can see that I now have a click me button that does nothing and a hello world. So now let's finish up this app with a couple more things that I want to show, and then we'll be done. The first thing is how do I cause something to happen when the click me gets pressed? Lots of different ways to do it, but the one on click property, and I'm going to do, I have to give it a name of a method. I'll say button clicked. And that means that there has to be a method in my main.activity called button clicked. So let's go in there and create it. Public void on click. Oh, what was it? What did I call it? Button clicked. View V. And here's, so we'll show you this idea of a log, android.util.log.diagnostic log. Button got clicked. So we'll see exactly what happens here. So now when I click the button, let's run the program again. When I click the button, we should see appearing on the log that the button got clicked. In order to do that, we use this guy down below. The Android monitor, when we look at the Android monitor, so we can do a terminal, we can actually do a terminal on the device, but Android monitor shows us all of the messages that get printed go to the log, either the error log or the standard output from any app running on the device. And you can see a button got clicked. I can clear this. So now let's do that. Go back to the thing and watch what appears. Right. So at February 17th at 2 o'clock, the app named Delete Me, there's my packaging for it. The D here stands for diagnostic. And this .get class, .get simple main, get simple name is activity. All right, so main activity, that's what caused that to print out, what I've got highlighted in blue, and then button clicked. There's my button clicked. All right, so that's one direction of a hookup between the view. All right, activity underscore main is the view, and in this case, the controller for that view, indicating that an event has occurred, the user has caused an event to occur, and I want to handle that event. All right. So now the next kind of hookup that we want to create is going in the other direction. All right. How can we change the contents of a text view? All right. So in order to do that, we have to get a hold of the identity. So I'm going to create a text view within the controller and connect it to the text view in the view, right? So this actually represents a text view object that exists in the view, right? This hello world is really a text view object that's placed in the view hierarchy on the app itself, and I want to make a connection from my controller so that I can actually affect what's in that. And in order to do that, I'm going to go here and create a member. So I'm going to call it private text view, my text view. All right, and I only have to initialize it there, but I am going to initialize it down here. My TV equals find view by ID, r.id dot, and then what did I call it? I think I called it my text view. Semicolon here. And find view by ID returns an object, so I need to cast that object to be a text view. And so now to complete the kind of hookup, I'm going to do the following. My text view dot text, set text to a character sequence. My text view dot get text plus my text view, or excuse me, plus, let's just do ouch. That'll work. So now when I press click me, you can see that the text view now gets ouch, 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 ouch. All right, so you can see now we've gone in both directions. From the view, activity main.xml, to the controller. Right, when a button gets pushed, there is an action event that occurs, and that action event is being handled by the button clicked by virtue of that property being added to the button in the view. And then as part of handling that action, I'm connecting to another UI object. In this case, it's a text view. I've called it my text view. I'm setting its text to whatever it was before plus the string ouch. And again, that's not good Androidism. And same thing here, although it's very common for you to not use r.string for that. So I didn't explain where that came from, r.id.myText. Again, R is a generated class, and any of the identifiers that get defined are accessible through that generated R class. And in this case, I'll show you the statement in here, this guy right here, at plus ID. Plus means add a new identifier, and the name of that identifier is my text view, and that identifier refers to the text view object that gets created, whatever that object is. Okay, so that's, that takes care of the very initial and simplest thing for doing an Android app. There's one more thing I want to show you in order to allow the first exercise to be completed. Let's see, first let's go back here. We don't have to wrap content or actually fill the entire parent. we can actually specify a specific width. So let's just say that we want this thing to be roughly 100 pixels high, 100 DP. That stands for 100 density independent pixels high. So now if I change it to that and then run it again, you can see that my button is now very, very fat. Right? So I can specify height and width in terms of specific numbers of pixels, or it's better to use density independent pixels, and you'll see that's exactly what's being done up here with the layout. Padding bottom and padding left and padding right are density independent pixels. I could do the same thing for width and height. So if I said my relative layout had a width of 200 pixels and a height of 200 density independent pixels, then in fact it would only fill up a small region of the UI. All right? So the first exercise actually asks you to go ahead and do that, to create another layout and actually another activity that will appear to overlay the existing layout. And you do that by adding a new activity to your project. You can do that with right-click and create a new Java class. All right, I'm going to cancel this, but I can create a new Java class and add it. And then adding a new layout, same thing. Create a new layout resource file. I can do that and specify it. And deserialize that new layout file in my new activity when it gets created. Then I simply have to define an intent in order to go from one to the other. There's examples on the websites, on the class website that shows how to do that. So now the other aspect of it is life cycles. So what happens in Android is that the app moves from view to view to view. And every time the app moves from one view to another view, what happens is that the old view gets a message, hey, you're about to be overridden by another view, or when you're moving to that view, you're about to be restarted up again. All right? And sometimes, depending upon what the underlying model is and the state of the controller, it's important to have an idea of when that's going to happen so that you can make sure that the user interface is in a consistent state and can actually be used. So the first assignment asks you to implement the optional methods. So here's the solution to it. I'm going to copy and paste these things out. Actually, it's not the whole solution, but it does contain the lifecycle methods. On restart, on start, on resume, on pause, and on stop. So I'm just going to copy those out of here. You can copy them from this video if you want to, although I don't know how you can capture the text. But I'm going to do that and go back to the delete me, and I'm going to paste them in here. All right, so now you can see there's a log.d, which is going to print something out when each one of these things gets called. So now you can see in our log, main activity start got called, main activity resume got called, and those are the only ones that get started. When a single activity gets started up, it's start and resume, but we can actually do this. We can end this and then go back and start it up again, and that should show, delete me, where are you? Right there. Restart, on start, and on resume, and button click. So you can see that each of those methods gets called when different state changes occur. So those state changes are all shown on the and described in the readings in the Busy Coder's Guide chapter on getting around Android Studio. And the same thing in the section, oh, I'm sorry, it's not there, it's down here. Android App Lifecycle. It shows the Android Lifecycle. There's a graph down here that does a great job. Here it is. So on create method, on start method, when restart gets called, and so forth while the activity is running. But then when another activity comes into the foreground, pause gets called. and when it gets restarted and so forth. So this kind of shows you the transitions that occur, and that's part of the readings for the course to go through and understand those. Okay, that's enough for this section. On the next one, we'll actually be looking at Android layouts and basic UI. So we'll go into more of the kinds of things that we typically put into Android scenes and views. Thank you.